Hello, everyone. I'm Emerson from Zapio, and this is our 14th SolMeet. And due to the current market sentiment, the people economy is not really much people, but SolMeet is still here. We won't miss out every chance to contribute to Solana ecosystem. So the topic we're talking today is, again, our universal rabbit hole. But this time is we are teaching people how to build an adapter for our gateway. So if you have attended our SOMI 12, you might have heard of what is universal rabbit hole. But for someone who didn't come, I think I would like to explain again what is universal rabbit hole. So for developer comes to Solana, they might notice one thing is a lot of programs in Solana we call program, not smart contract. A lot of programs aren't open sources, which means the developer is hard to integrate a lot of different protocols because they need to spend a lot of time on reading their SDK, and sometimes they can't even find the sources to maybe interact with their protocols. But Zapier thinks, we think that integrate with different DeFi or NFT shouldn't be that hard. So we provide a plug and play framework we call Universal Rabbit Hole, which is a useful tool for developer. So let's see what problems we're solving. Let's say the first rule in this ecosystem is protocol developer. You can imagine that if you are a new coming team to Solana, you want to build a project. Maybe it's a DeFi project, or maybe it's an NFT project. What's your goal is? Your goal might be acquiring more TVL and exposure. So you need to think what you can achieve this. As a newcomer, if exist protocol can integrate your protocol, that might be a great chance for you to get more exposure. So Universal Rabbit Hole provide this advantage for you. Because we provide a composable service. We'll say it an adapter, which means you can easily provide the composability by building an adapter to Universal Rabbit Hole. And the other protocol might easily interact with your protocol. So this is for protocol developer. And for dev builder, the problem is you need to read a lot of SDK. And the SDK might be really diverse from different protocols, which means you need to spend a lot of time reading the SDK and you need to figure out how you can use it, and it really is a time-consuming process. So to solve this problem, Universal Rabbit Hole provide universal interfaces, which means if you read our SDK, and you can see that like we provide pool interfaces for some protocol who provide a liquidity function. And like farm, you need to have a stake process, like you can stake your LP token inside the protocol. We'll standardize all these different functions to universe interfaces, which means for that builder, you just need to understand our framework and you can interact with all different protocols. without reading all the SDK. You only need to read one SDK. It's our SDK. Okay, and for the end users, due to the hard building process of current situation, so there are limited DeFi choices on Solana. So if we can make the barrier lower, that might have more DeFi innovation in Solana ecosystem, which means user might have more DeFi options in the future. This might benefit the users at the end. Okay, so the universal rabbit hole provide as composability as a service, which accelerates the developing process, makes NFT and DeFi programs more composable on Solana. Okay, so you can use our program, use our framework easily to do like radium swap and add liquidity to Orca, and maybe you can deposit some LP token to vote like this. Okay, and also we provide the uniform interfaces as I mentioned before. So you just need to understand what these interfaces means, then you can build your own dApps easily. So let's take a look at if you build a program without universal rabbit hole. First, you need to read a lot of like SDK A, B, C, and you need to understand how their program works. And after you understand all this process, the data, you need to parse it by yourself and format it to your self-defined format that can interact with different protocol. This, just as I say, is pretty time-consuming. So, if you have a universal rabbit hole, how would the developer process be like? For that builder, you can use our TypeScript client-side library. It provides a reading function for different protocols. And also, as I say, it have a uniform interfaces, which means you can easily interact with different protocol, and the data can be synced up as a same format. And for protocol developer, you'll need to use both client-side and also the on-chain program called Gateway. And Gateway, the relationship between Gateway and the base program, like Radium, Orca, etc., we'll use an adapter program to link our gateway with the base program. So if you're a newcomer, you'll be a base program, and you just need to build your own adapter, to fit our gateway. So other protocols can leverage through this framework. Okay. As I say, we have two client-side libraries, one called Navigator and one called Gateway. A Navigator provides a reading function. It will parse different protocols' data to a uniform layout. And for Gateway, it will pack the instruction and pack the instruction you want to use to a series of transactions and pass it through Gateway on-chain program, and you can make all these things happen. So this is Gateway and Navigator. And here you can see these are all protocols we are already integrated. You can see Radium here, Orca here, Saber, Infinity, etc. Okay. So let us take a closer look. Okay, this is the we talk how to build a aggregator, simple aggregator in our SolMeet 12. And if you are interested in, you can check out this document yourself, or you can. We have a ebook called book.solmeet here, book.solmeet.dev. In here, you can see all the process, and you follow the step, and you can build a simple aggregator with our framework. Okay. So today we are talking about how to build an adapter. So we need to understand how's the adapter look like first. Here is the structure I just mentioned here. If as a user, when you are using our framework, it will use a builder in the gateway TypeScript library. And in here, you can see a lot of protocol here. And it will, like you want to use Radium swap and add liquidity to, like, say, Orca. And also you can stake your LP token into other protocol. Yeah. And builder will pack all this transaction and send it to gateway on-chain program. And how does the things happen? How does the things happen is we store the state on an account during initialization. And the gateway state will pass through all the transactions. So, and when it processes one transaction, it will update gateway states. So the update states will be passing through second transaction and third, and so on. So that you can chain all different protocols action together with a series of transactions. And if you process from the first initialize and step 1, step 2, step 3 to the end, you can finish all the process you want. Okay, so let's see this example. I'll open a larger image right here. Let's say we are going to zap in a token. Zap in. I think I need to define a zap in process. Zap in process have 3 steps. The first step is swap, and then add liquidity, and then stake. Okay, so here's how your process will be like. Here you are the user, and you interact with our gateway client side. Okay, and here is the off-chain part. So, like I say, you need to swap first, so our gateway client will generate the transaction for you, and then return the builder. And second, you generate a liquidity part, and also generate the transaction. And the last is stake. You generate the stake again. And also, if you finish all you want to do, we will have a function called finalize, and it will format the transaction in the right sequence, and with the initialize and close in the end, in the beginning and the end. Okay, and you can get all the transaction you want by transactions function. And then if you have all your transaction, you just need to sign your transaction, and this process will send all your transaction, and then you can send all your transaction in sequence to the on-chain program. And we can see that actually on-chain part is doing the same process as we mentioned here, swap, add liquidity, and stake in sequence. But the things is we have update the gateway states. So you can see in gateway program, right here. He read the gateway state, and in the adapter program, he read the gateway state again and passed the gateway state params to the base program. Okay, and after that, he will update the gateway state. So just repeating this process, you can pass the on-chain states through all different protocols. Okay, so that's it. I think this is how our universal rabbit hole works. Okay, so here you can see all the program ID. We have already deployed it on Navigator. So here you can see here different adapter. We have defined their type. So, and if you are interested in what the different type means, you can check out our GitHub repo. Like Navigator here, you can see in the source, we have defined the types right inside here. So like pool, we have defined you need to have a pool ID, and also pool you need to provide the liquidity. So it might have two kind of token mints, and also provide a LP mint. And you can see down here, like pool, we have defined all the functions they need to instantiate. Yeah. So yeah. We have open source Navigator and adapter program, and also adapter program. Yeah, I think we just open source this tool in our SolMeet 12. Yeah. So yeah, if you're interested in it, please check it out. And I think this is the first part of our SolMeet event, and we would like to have a short break, and later on we'll pass to our another developer way to explain how we integrate the Genopaths form function. As I think I would like to introduce a little about Genopaths. Genopaths is a project, is a GameFi project. It's a move to earn project, and also currently it have provide a stake function that it can stake their Gene token to their farm. And in the near future, they will provide their Gene and USDC LP token to stake. And in this example, we'll teach you how to implement the adapter to build a Genopath form adapter that you can interact with their program, and you can actually stake their Gene token and also their LP token on our mainnet fork. Yeah, so it's just a testing example. Okay, so that's it for the first part. Thank you.
Yeah, let's start from mapping the adapter to the base program. So we first have to know what we are going to integrate for this protocol or this program. First, we can see in Gene's platform, there's a staking functionality inside their DApp. So first, we need to know the instructions or all types of actions we can do inside their website, and we need to map it to the adapters we're making. Yeah, first you can see in their website you can stake your Gene, and you can claim your rewards here, and you can also view all of the stakes and the rewards you just claimed. With every reward, you can withdraw as Gene token or withdraw as Gene token. The difference here between other farm such as Radium or Oka is that the LP tokens or the token that you put into for farming has to be locked at least a month before you want to unstake or withdraw. So that's the first difference. That you cannot unstake instantly in Jin's farming protocol. The next thing is the harvest is a two-step process. So after the reward is distributed, your reward will be locked for a year. In that, you can only withdraw the Jing token after this 1 year period, or you can withdraw as SJing instantly. But this SJing token cannot be transformed back to Jing token later. It is only for in-game usage. You can see here what is harvest type. So after you initiate your harvest, the Jing reward will be in a new staked account. You can now call claim reward instructions after a year, or call withdraw as a string instructions instantly. So this is different. The first step is to claim rewards and withdraw as and you have to choose between these two steps. So now we know the mapping of the program. There's stake, harvest, and unstake. And in a harvest, there's 3 types of actions. There's claim reward, withdraw as string, and withdraw. And in unstake, in the stake account, there's a field is called STL. If the STL is false, it means this is the token you just lock inside for farming. You need to call unstake to unstake it. If the stake account is yield, because it means your reward is from your stake account is from a reward. So you call harvest to withdraw it. So what's next? We now know the mapping to map the base program to the adapter. We now need to write the adapter program to connect with the base program. So we just talk about the harvest type, and we will now talk about wrappers. There's two kinds of wrappers inside a adapter program. You can see here, there's stake input wrapper and stake output wrapper. There's 2 types of wrapper. First is input wrapper. Let me talk about the input wrapper. So in gateway, it will build an array of bytes, and the length is about 32 bytes. After it built, the inputs is passed inside to the adapter program in the instructions data. So you can see here the stake instructions inside inside the Genopath adapter. There's an input byte array. The byte array has the structures declared inside the second input wrapper, so it can be deserialized and use the data that we needed. The input wrapper here is the data we needed for the base program. So in this instruction is stake. The stake instructions need 2 types of data. It needs how much token you want to stake and how long you want to lock your token. You can choose between 1 month and 24 months, that's 2 years in Genopath. Yeah, so the input wrapper is for the inputs of an instruction. And the main logic here, you can see where we use the input wrapper. After the input is passed in, it's deserialized and use it as a input structure for later. And next, let me talk about the class and the helper functions that we use to help us write less code, and it's more easier to read. Here, there's a low token account imbalance functions, and this is for tracking a token account's balance changes. When you call low token account imbalance, a account will be lowered as a token account and will take the records of the amounts that's inside the accounts before the invocation of the base program. So what's here is, you can see inside the main logic, there's, after you build the instruction data, you load the token account and balance here. So in staking instructions, we load the stake token account. So which token will be staked into the protocol. The token account balance will be tracked. And inside here will be the balance before the invocations and the token account itself. Okay. The next helper function is called low remaining accounts. Because in an instructions, the account info inside context is typed as account info array, and this array contains all kinds of metadata, such as LAN ports, account size, and owner. But what we really need is the key and the is writable and the is readable tag. So here we pass in an index array to. The index array is to reference the remaining accounts index that we are using for the invocations. So all the keys is declared inside here. So within the index array, you can now build the account meta for the invocations later. So this is a very easy for loop that contains an if-else statement. You can see if a remaining account is writable, and it will be pushed as a account meta that is writable. If it's not writable, it will be passed as a read-only account meta. So this is quite simple. You can see in the main logic here, the index array is like this. So in here is just 0 to 17. But if there's any account that is reused inside these instructions, it can be like this. So it can be duplicated at some points. And you can see in the main logic, we just covered like from the input visualizations, making the instructions data, and loading the instructions keys for later, and we just track the token account balance. The next thing is just to invoke the base program. After the invocations, we need to know what's the output for these instructions. So the output here, the output structure is also declared in the output wrapper. So you can see in the output wrapper, there's a token in amount. So this amount is to return the amounts that you just staked to the farm. And this amount is tracked by using the token account and balance we just built right before. The next thing is to build the output byte array. So the output byte array here is the structure is just like this, but you might wonder what's the dummy for? Yeah, because in Gateway we make the output length 32 bytes long. So with this is 8 bytes for the token in amount that we are using, but the rest of it we have to fill it with zeros to meet the need for gateway. So here you can see the output is serialized, is first built in the structures, and the token amount is get from the balance changes. And we build a new output array, serialize the output array, serialize the output, and we build a byte array for the return results. So here we return the results and log it to the log windows, and you can see this is this is all we do in a instructions of a data program. So this is for stake, and the stake uses the stake instructions inside the base program, and this stake hash is for invoking a anchor program, and this is for building the discriminator. That's the first 8 bytes in the instructions data. So you can, and next we move on to unstake instructions. The unstake instructions didn't need input because the unstake instructions will unstake all of your stake when you call it. So the input structure is blank, and the unstake data is all the same every time. It's called withdraw. And this 0 we push it in the last of the array. It's a duplicated data it's a duplicated data for genopads because it now has other type. It's not used here now. The next thing is just the same. It's another index array, and we load the remaining accounts, and we load the instructions accounts from the remaining accounts, and we check the balance changes for the token you are unstaking. We build the instructions and do the invocations. Next thing is also the same. Just wrap the output and return it. So in stake and unstake it's all the same. The only difference is the instructions data and the remaining account index. And the next thing is after unstake, we move on to harvest. The harvest is the different parts from previous two instructions. So we just talk about the harvest type inside genopads. The harvest type here, there's three types of actions. So we use the harvest type. We use the harvest type input from the input wrapper. So there's only one input. It's called harvest type. So you choose your type inside the TypeScript SDK and push the account data here. So the harvest type here, if it's 0, is for initializing the harvest. So it's called claim rewards. And 1 is for complete as string. It's called withdraw. So if it's 1, and it will withdraw as string token. If the match is 2, it will withdraw as string token. Yeah, this is pretty much the difference between harvest and stake unstake. So the rest of it is the structure is the same. So first you take the inputs, visualize it, and use the harvest type as for matching. After you build all the data and the index array and token account index, you just load the instructions account from remaining accounts, check the harvest token account balance, build the instructions and invoke it. After the invocations, you just grab the outputs and return the result. Yeah, this is pretty simple inside adapter program. So when you want to build a new adapter for your program, you just need to know what's the inputs, what's the outputs, what's the account look like, and what will the data be like. You can integrate all kinds of instructions inside your adapter. So we're just using GenoPath for an example here, and it only contains the farm program here. But in other protocols such as Orca or Radium, they have AMM ports and farming and staking inside their protocol. The instructions you can just add more. So that's such as swap, add liquidity here, and the adapter here is all about it. You can use all the helper functions and the classes we just used to build your own adapter. And after we implement the adapter, we will move on to the Navigator part. So as Emerson just said, the Navigator is for reading the unchained state and put it into a object that's readable. So you can see the instance for the instance form. So this is for the farm instance. All kinds of functions you need to integrate for GenoPath. So let's get all farms, get farmers, and get farmer ID. So during the implementation, there's two things we need to be aware of. Info must contain all essential data for write functions. So all the infos inside a farm info, we need to put all the accounts or keys inside the infos for later to use inside gateway. So gateway will get all the token key, get all the account key from the infos, and try your best to reduce RPC requests. You can use like get multiple accounts or get program accounts just to make sure in every functions you can use as less RPC requests as possible. Because RPC request is slow and it costs lots of time. If we stack up all kinds of functions we use here and the RPC request is like 100 for each one, it will be pretty harmful for your performance in your website. Yeah, there's also optional methods inside the instance. So some protocol you didn't need these kind of functions, but it all depends on what is used inside this protocol. Yeah, let's move on to the code for the Navigator. The Navigator here is divided by 3 to 5 parts. So there's an ID file. It contains only the program ID and some ID that is always constant. So in GenoPath, there's the farm program ID and the farm master ID. So the farm master is all the same across the whole farm. It's across all the farms. And you can see inside the index file, there's the account, the data structures of the class of the interface, the farm info interface. So inside the farm info, there's all the data you needed, and it's all from unchained data. And there's like 3 kinds of accounts on chain. There's farm master, there's a farm info, and there's a farmer info. So farm info is for checking checking your stake account, and it is different from all your every wallet. So inside the farming info, there's array of farmer instance. So in the farming instance, it check every stake account. So you can see here in the website, each of these rewards or deposits is tracked inside a farmer instance. And we can move on to the function parts that we implement all the fetching functions for GenoPads. You can see here this get all farms. So we use a get program account call to get all the farms account info, and we pass them to a farm info object, and we return a array of farm info. And this get farms is for single farm only, and the next is get all farmers. So this just get the stake accounts for end user. So here there's another parameters called user key. So this is for the wallet address, your fetching for the wallets. And there's also some static functions to get the PDA of the program. So there's farmer, you need the seeds and the user key to get the farmer ID, and you also need to write the stake amounts to get APRs, but this is optional inside a farm wrapper because the APR here is the calculation is different from every protocol. And the staked amount is for how much stake is inside a farm in the whole system. And this is not integrated yet, but this is an optional. You can do it inside a wrapper. And there's also get farmer instance, because in GenoPads, every stake or every stake account, every instance is inside, there's an index inside every instance. And every time you deposit or you stake or unstake or you claim your rewards, there will be a new instance that is created. So the rewards or deposit is stored inside. And this is just for the index we're using. This is for later to use it inside the gateway. And there's also account layout file. The account layout file is copied from the IDO file that GenoPads gave us. So there's all kinds of accounts. There's staking pool, there's stake masters, and there's also staker deposits. And yeah, that's all the accounts that is on chain. So the structure here is copied from the IDO file, but it's quite easy. So the type and the name is all in the IDO file. Just use it as this layout or this, and you can parse or deserialize all the accounts that you needed. And this is all that we do inside a Navigator. So now you can read all the states and all the keys and all your stake or farms inside GenoPads. And this is Navigator. Okay, maybe I can run the test file for GenoPads Navigator, so you can know what it's doing inside. So the test file just fetch the states from the RPC. So it fetch all the farms, and it's just for testing. It's just for testing if the functions are all working correctly. Yeah. So as you can see here, we log the farm info out, and there's a farm ID, and all the weights, times, and how much the stake is weighted, and how much reward is distributed. It's all inside the farm, and you can see the farmer that created for this wallet, and there's like 49 instances inside the stake. Just so all of these, so it's from some of them are missing because it's closed. So all of these is actually what you're seeing here. So there's all the instances, and we fetch them correctly. That means the navigator is working just as we intended. And the next part is implementing the gateway clients. So after you build the adapter program, and you can read all the states from the on-chain data, the next thing is to build a client for the gateway program. So this is the TypeScript part of the gateway. But the Rust part of the gateway, so the gateway program itself is now closed sources, and we will handle the implementation for you. So you only need to submit the data program, the navigator, and the gateway client, and we can help you to put your program inside the gateway and for testings. Yeah, so we're not talking about the gateway part now, but after we open source it, we will have another class or sessions to talk about it. So let's move on to the gateway client. So gateway clients is just to build builders. There's like swap, add liquidity, remove liquidity, stake, unstake, harvest. But what we are now using here is just stake, unstake, and harvest. So we can open up the gateway clients file. You can see here there's a Geno patch inside the protocol. First, we implement the farm protocol and call it protocol Genofetch. And the constructor is all the same between all the protocols. So there's like 3 functions inside this class. First is stake. So stake takes in like stake parameters, farm info, and user key. All these parameters is declared inside farm protocol instance. So the parameters is all the same between all. It's the same between all farm with different protocols. You can see here we implement the stake functions inside Francian, Genopass, Larix, Orca, Radium, and Saber. This is all the parameters is all the same, and the result is a transactions array and the input buffer. So for Genopass staking, we build up the payload for the instructions data, and it's passed and it's returned later here. The next thing is we declare the metadata, so the lock duration is inside the gateway parameters. So the lock duration is passed outside is passed inside the stake parameters. And next thing here is to handle the transactions. We first fetch the farm info. We get the farm info from the builders, and after we take all the IDs that we needed, such as the deposit, redeposits, and put it into and we'll use it later for the account key. The next thing is to know the token account address for the user. So here is user's pool token address, user's gene token address, and the votes for the fund. So this stores the token you just staked in. And there's also pre-instructions pushed inside. These three instructions is to create the token account if it's not created. And next thing is building up the remaining accounts array. So this account is all, so you can see here that this is all the indexes. So what the index is used for? Yeah, that's what we just talked about is inside the gateway. So you can see here, the index array is just looks as the same as the remaining accounts here. So this from 0 to 15. Yeah, so this is all the accounts that we are passing into stake instructions. And next thing is to call the stake and the accounts. Yeah, so the transactions will be built, and the remaining account and instructions is all stuff inside these transactions, and you just return it. And it's all the same across stake, unstake, and harvest. The structure is the same. The difference is just what kind of account you're using and what's the input is here. So you can see there's list names or the so-called account inputs, input layout. The name here has to be exactly the same because this structure we're using is not using a TypeScript library. It's write it inside JavaScript. So it will not check the names or the types here. We have a mistake that we mistype here, and this is like the uppercase, and this is the lowercase, and the parameters were just not passing inside the structures, and this will always be 0. So make sure your typing is correct between the structures and the encoding. Yeah, that's all about the gateway clients. So the main goal of a gateway client is to build up the transactions that is needed for all the actions. So in stake, we just talk about, and the next is unstake. Unstake is basically the same. You also need to create the token account and the remaining accounts, and you just call the unstake instructions, and the transactions is built. And it's also the same in harvest. The harvest, there's a little bit difference for harvest because we need to know the harvest type. The harvest type is in the harvest parameters, and the type here, you can see the type. There's like 3 kinds of type: initialize, complete as string, and complete as string. And this is 0, 1, and 2. It's just the same inside the adapter program. So 0 is for initialize, 1 is for complete as a string, 2 is for complete as a string. And that's it. That's for the gateway client. The rest of it is all the same. Just build it transactions and return it. Yeah, this is all we need to implement a base program to gateway, including making an adapter, making a navigator to read all the states, and making the gateway clients to build the transactions. The last thing to do is to write a test. So a test here is just a simple sort from USDC token to Gene token and add liquidity to Radium LP. After make the LP tokens, you stake into the farm. And the next thing is to send the transaction. And we can try to send a test here. Let me try. Adapter genome pass. Something needed here. Okay, so there's all kinds of accounts that's missing inside Jupyter, so it will be a workaround here because we're using main and fork. I think there's tons of accounts that is missing, so I have to like try it again and again. Weird. Make sure the request is going through here. Nah, there's something wrong. There's something wrong here. Therefore, okay. Oh. Script. Jupyter. Oh, I see. Turn this on. Let's open the public. More account to go. Oh shit. Yeah, maybe I will just disable the Whirlpool AMM here. That will be much easier. Oh shit. Sakura. Okay. What's next? Which account is this? Open book. Oh, yeah, open book. No, no open book. We're not using open book here. This is the old SDK for Jupyter, and many folks have no open book account on it yet, so we just skip it. Well, more to come. Account owner. Yeah. Missing. Wow. What's going on here? Radium and I see. Ah, it's from Radium and shit. Yeah, but yeah, after we need to use Radium here. Bad news. Okay. Radium and yeah, I think that will be. I'll try. Oh, it's a 6. Weird. You can see if there's any. Yeah, there's no. Oh, this is initialized with a swap. Oh, there's actually a swap here. It's down from Orca. Whoa. Yeah, so after the swap, you swap from USDC to Gene token, and you add liquidity to Radium LP. You can see here. You add liquidity, and the amount is 100. And the output here, you can see the LP token is like 72,000. And next is to stake the LP token, and you stake. You can see the amount here is actually passed from the previous outputs. So this is all done from gateway. So this is the magic about gateway. So that every output before is passed into the next input. You can see the LP amounts here is the output, and the next thing here is the input for the LP amounts that is inside stake instructions. Yeah, stake instructions, and this is just to close the gateway stake account. Yeah, it's you just pass. Oh, the next is to harvest and unstake. So this one should be harvest. You can see here. Oh, this is unstake. Weird. Harvest. Initialize. Unstake. Remove liquidity. Swap. Maybe it's the reward here is different. Automount, slippage, tokening amount, version, finalize. Yeah, let me see the test file. I think I just deleted something. Where? Hmm. Oh, here? Oh, yeah, harvest is, oh, okay. Harvest parameters. I see. So we harvest, the difference here is like, oh, I see. Oh, yeah, there's different type of harvest. I should use harvest one here. Let's try it again. I run the script again. Cool. Yeah, the transactions pop up this time. Yeah, you can see there's harvest. You harvest 69 of the tokens. I see. Oh, yeah. So that's all we needed to build a adapter and the clients for any programs, and it's all handled like you can see in the test file. The code that you need to interact with all these protocol is quite simple. You just know the pool ID. So this is Gene USDC pool. And the swap parameters is just swap from USDC to Gene token and the amounts, the slippage. You add liquidity. And if you want to change the protocol you're using, just to change one line of code, you can add it to another protocol. And the next thing is to get the farm from GenoFats, and the farm is used, and you just stake into GenoFats farm. And next is just to call like gateway.swap, gateway.liquidity, gateway.stake. So this action is executed one after another. So we first do swap, liquidity, stake, and the finalize just call we build up all the transactions and the gateway stage, initialize it, close it. All the transactions is you can call all the transactions by gateway.transactions, and you just sign and send it. And this is how you handle all the transactions and all the reading, writing using gateway. And this is just a couple lines of code. This is what we want you to know, that when you integrate your program into gateway, and it's pretty easy for other devs to use your program or use your protocol. And this is how we this is how we done. This is how we integrate everything and still maintain the composability of the gateway. Okay, that's all. Thank you for listening.